It was 1943. Germany was in the midst of the Second World War, and the Luftwaffe faced a new and pressing challenge. The swift, agile aircraft of the Allies were beginning to outclass their German counterparts. One machine in particular caused serious concern: the British de Havilland Mosquito. Fast, versatile, and notoriously elusive, it threatened to undermine German dominance in the skies. At this critical moment, German designers were desperately searching for a solution that could shift the balance. Among them was Claudius Dornier, an experienced aircraft engineer who proposed an unconventional concept: a fighter powered by two engines mounted in tandem, one in the nose pulling the aircraft forward and another in the tail pushing it from behind. From this idea emerged the Dornier Do-335 Pfeil, Arrow, a machine that promised to be a breakthrough but ultimately remained overshadowed by the rapid advance of jet technology. It embodied unique engineering solutions and ambitious goals, but its fate would unfold differently. The Do-335 stood apart from all other aircraft of its era. The tandem engine configuration, a tractor propeller in the nose and a pusher propeller in the tail, offered the potential for very high speeds with minimal aerodynamic drag. In theory, it could have been one of the fastest piston engine fighters in history, capable of reaching up to 773 kilometers per hour. But did this remarkable aircraft truly meet expectations in combat conditions? And why, despite Germany's urgent need for a modern fighter, did the project never reach full-scale production? To answer these questions, we must first look at why the Luftwaffe needed such an aircraft in the first place. By 1942, the air war over Europe had become a severe test for Germany. Allied bombers, especially the British de Havilland Mosquito, posed a growing threat. Built from plywood, the Mosquito could reach speeds of 668 kilometers per hour, and combine this with a versatility that allowed it to operate as a fighter, bomber, or reconnaissance aircraft. German aircraft such as the Bf-109 and Ju-88, which had been highly effective early in the war, were losing their competitive edge. The Bf-110, once considered a universal solution, had by 1942 earned the derisive nickname "meat on the table" due to its vulnerability in daylight combat. Even the Ju-88, successful as a night fighter, could not match the Mosquito's speed and maneuverability. The Luftwaffe urgently needed an aircraft that could combine high speed, versatility, and a meaningful bomb load. In 1942, the German Air Ministry set out its requirements: a twin-engine aircraft capable of reaching up to 800 kilometers per hour and carrying up to 500 kilograms of bombs. It was an ambitious demand, given that piston engine technology was already nearing its limits, while jet propulsion remained in the early stages of development. Claudius Dornier, one of Germany's most seasoned designers, saw an opportunity to realize a concept he had been developing for years. His long career began in 1910 at Zeppelin Luftschiffbau, where he worked on aerodynamics for metal structures. During the First World War, he designed flying boats, including the Arzai, the first German aircraft built from duralumin. Dornier's signature approach was to favor metal over wood and to use tandem engine layouts, a configuration he had successfully applied to large flying boats such as the Armament Saibi, which used 4 engines mounted in push-pull pairs. This background provided the foundation for the Do-335. He understood that the tandem arrangement could give the aircraft both speed and aerodynamic efficiency, thanks to clean, unobstructed wings without bulky engine nacelles. The only question was whether modern engineering could overcome the technical challenges that had held this design back for decades. The tandem configuration had a long and checkered history. As far back as the First World War, aircraft like the Fokker Ki had used a front engine with a tractor propeller and a rear engine with a pusher propeller. In the interwar years, similar experiments were carried out in the Soviet Union with the ANT-23, in France with the Arsenal VG-20, and in the Netherlands with the Fokker D-3. All had run into the same problems: vibration from the long drive shaft connecting the rear engine to its propeller, and reduced control surface effectiveness because the tail lacked the airflow from a front-mounted propeller. Dornier knew these flaws well, but believed that modern technology could finally overcome them. His goal was clear: to create an aircraft that not only met but exceeded the requirements of the Reich Air Ministry, serving as both a fighter and a bomber. In 1937, he was granted a patent for a tandem engine aircraft, describing a design divided into 3 sections: the forward fuselage with the tractor engine, the central section with the cockpit and systems, and the rear section with the pusher engine and cruciform tail. The patent also included armor protection for the cockpit using steel plates to improve pilot safety. This patent formed the basis for the P-59 project, which would later evolve into the Do-335. The journey from concept to operational aircraft, however, would prove long and difficult. Germany, consumed by the demands of war, was reluctant to invest in risky designs, and competition from other engineers, especially Willy Messerschmitt, made the road even steeper. The tandem configuration chosen by Claudius Dornier for his aircraft had a long history, marked by persistent technical challenges. As early as 1911, the French Aigo Torpille used a rear-mounted pusher propeller but failed due to severe vibration from its long drive shaft. Similar problems plagued the De Broglie aircraft of 1917, which crashed after only a few meters of flight. The main obstacle lay in the fact that the rear engine, positioned within the fuselage, had to transmit power to the propeller through an extended shaft, causing strong vibrations. A pusher propeller also reduced rudder effectiveness, as the tail surfaces received no propeller wash, unlike in conventional aircraft. A twin-boom layout could have solved the driveshaft issue, but it created too much aerodynamic drag for a high-speed fighter. Dornier understood these limitations, but his prior experience gave him confidence. His flying boats, including the Doge Wall, had already used tandem engines mounted outside the fuselage, which simplified the layout. In 1937, after securing a patent, he began work on the P-59 project, which included 4 design variants. The most promising was the P-59-04, a single-seat, low-wing aircraft with 2 Daimler-Benz DB601 engines, each producing 1,250 horsepower and capable of speeds up to 755 kilometers per hour at 5,000 meters. Notable features included a cruciform tail to protect the rear propeller during takeoff and landing, and wings with adjustable sweep, up to 20 degrees, set on the ground before flight. These innovations aimed to make the aircraft both fast and maneuverable, while remaining safe to operate. To test the concept, Dornier turned to Dr. Ulrich Hütter, who designed the experimental Göppingen Go-9. Built at the Schempp-Hirth factory in Wusterberg, the aircraft was a scaled-down version of the Do-17, fitted with an 80-horsepower Hirth HM60R engine mounted behind the cockpit and driving a 4-bladed pusher propeller. The Go-9, registered as DEBYW, made its first flight in 1940 at Mengen Airfield, towed behind a Do-17. In subsequent powered tests, it reached 220 kilometers per hour and demonstrated that drive shaft vibration could be reduced. The results were promising, but Reich Air Ministry officials remained skeptical, viewing the design as too risky compared to proven types like the Bf-109 or Ju-88. The Go-9 featured a cruciform tail similar to what the Do-335 would later use, and tricycle landing gear with a nose wheel, providing the clearance needed for the rear propeller. Testing continued into mid-1941, confirming the basic viability of the tandem layout while showing that significant refinements were still required. Dornier continued to champion the potential of his concept despite bureaucratic resistance. In 1940, Hermann Göring wrote to Minister Funk stressing that resources should go only to projects capable of delivering results by the spring of 1941. This put the P-59-04 at risk of cancellation, but Dornier persisted, believing that shifting wartime priorities could eventually bring his design into demand. Alongside work on the P-59, Dornier explored new ideas. He experimented with air intake placement for the rear engine, situating them in the fuselage sides behind the cockpit to reduce drag. He also proposed armoring the central fuselage with steel plates several millimeters thick to improve pilot protection. These concepts fed directly into the later P-231 design, which would become the Do-335. Dornier even considered mixed power concepts, such as the P-2313 with a Daimler-Benz DB603 piston engine in the nose and a Jumo 004 turbojet in the tail, but ultimately chose a pure tandem arrangement with 2 DB603s. The cruciform tail, fitted with a lower fin extension acting as a tail bumper, prevented propeller strikes on the ground, while the nosewheel gear made ground handling easier. The technical challenges remained considerable. The long drive shaft linking the rear engine to its propeller generated vibrations that affected stability. Flight paths tended to oscillate slightly due to unequal torque effects from the two engines, making accurate gunnery more difficult. The pusher propeller also posed an obvious hazard during bailout, and there was always the risk of propeller damage during takeoff or landing. Yet the tandem scheme had clear advantages. Very low aerodynamic drag thanks to clean, nacelle-free wings, ample power reserve, the ability to fly safely on a single engine without asymmetric thrust, improved cruise economy, and the rear engine providing some protection for the pilot from attacks directly behind. Dornier had extensive experience with such layouts. His flying boats, such as the Doge Wall and Do-18, used similar push-pull arrangements with engines mounted outside the fuselage. In the Do-335, he went further, housing the rear engine within the fuselage, which necessitated the cruciform tail for propeller protection. This reduced vibration but made the structure heavier and more complex. He also investigated twin fuselage designs, as in the P231 2.03, but returned to the tandem concept for its simplicity and efficiency. By the early 1940s, advances in engineering had begun to address some vibration issues, as seen in the American Bell P-39 Airacobra, which used a driveshaft in a conventional single-prop layout. Dornier drew on this experience to refine the P-59. Working closely with Schempp Hirth, a company renowned for its glider expertise, Dornier developed the GO-9 as a key step in proving the tandem concept's feasibility for a high-speed fighter. The test showed that vibration could be kept under control, while the nosewheel gear provided good stability on the ground. Nevertheless, the Reich Air Ministry's leadership remained unconvinced, favoring jet projects like the Me-262 and dismissing the P-59 as too experimental. Dornier pressed on, convinced that the changing course of the war might give his aircraft a chance. In 1943, the P-231 project received its official designation, Do-335, and the name Pfeil, or Arrow. This aircraft was intended to be a truly versatile platform, capable of fulfilling fighter, bomber, and reconnaissance roles. Dornier worked tirelessly to reduce vibration and improve control surface effectiveness, experimenting with new exhaust shapes and wing leading edges. He again considered the use of a jet engine in the rear position, as in the P-2313, but ultimately committed to the twin DB603 piston layout for its reliability and availability. By the mid-20th century, the Dornier Do-335 Pfeil had progressed from drawings on paper to a fully realized aircraft. The P-2312 project, officially designated Do-335, was the culmination of years of work by Claudius Dornier. The machine was powered by two Daimler-Benz engines, each producing 1,750 horsepower, giving it a top speed of up to 773 kilometers per hour at an altitude of 4,000 meters. The design was bold, a single-seat, low-wing aircraft with a tandem engine layout, cruciform tail, and tricycle landing gear with a nosewheel. The first prototype, Do-335 V1, completed ground trials in September 1943, and on October 26th made its maiden flight at the company's Friedrichshafen airfield. At the controls was Dornier's chief test pilot, Hans Dieterle, famous for setting a world speed record of 746.6 kilometers per hour in the Heinkel He-100 V8 in 1939. The Do-335 V1's first flight made a strong impression on observers, including General der Kampfflieger Peltz and Colonel Peterson from the Rechlin Test Center. The aircraft displayed exceptional speed and handling while also revealing several flaws that would require refinement. One of the Do-335's most notable innovations was its pneumatic ejection system, a necessity as the rear propeller and cruciform tail made a standard bailout hazardous. The system worked in sequence. The first control jettisoned the rear propeller, the second blew off the tail unit, and the third armed the ejection seat. The pilot would then jettison the canopy and pull two handles to launch clear. This made the Do-335 one of the very first piston engine aircraft to be fitted with such a system, alongside the Heinkel He-219 and the Swedish Saab J-21. Aerodynamically, the aircraft had several distinctive features. Its wings, with a sweep of 13 degrees, had a sharpened leading-edge root to improve low-speed performance during takeoff and landing. Air intakes for the rear engine were positioned in the fuselage sides behind the cockpit to reduce drag, while the oil cooler for the forward engine was integrated into the annular radiator, creating the visual impression of a radial engine. The tricycle undercarriage retracted in flight. The nose wheel folded into the fuselage and the main wheels into the wings. Retraction took 15 seconds, extension 20 seconds. The main gear featured independently operated disc brakes, and the ventral fin carried a tail bumper to protect the rear propeller during 3-point landings. The fuselage was built around 24 frames with stressed skin construction. The cockpit, located aft of a firewall, was equipped with an armored seatback and compressed air bottles for the ejection system. On early prototypes, the canopy hinged to the right. The Do-335 V3 introduced a complex mechanism that first lifted it upward, then slid it back, a feature later abandoned for simplicity. The wings housed fuel tanks, oxygen bottles, a hydraulic reservoir, and a twin landing light. The gyro compass, usually fitted in the tail, was moved to the left wing since the rear fuselage was occupied by the pusher engine. Flaps deflected 30 degrees for takeoff and 50 degrees for landing, providing additional lift. Engines were DB603A1 and DB603QA2 on the A0 pre-series, or DB603E1 and DB603QE1 on the A1 production model, each separated from the fuselage by a firewall. The forward propeller was a 3.5-meter VDM unit with variable pitch. The rear propeller measured 3.3 meters. The Do-335 V1 initially flew unarmed, but later prototypes such as the Do-335 V5 carried a 30mm Mk103 cannon firing through the propeller hub of the forward engine, along with two 20mm MG151 and 20 cannon mounted above it. The internal bomb bay could carry up to 500 kilograms, one SC-500 or SD-500 or two SC-250 bombs, and the wings could mount ETC-501A1 racks for additional SC-250s. Radio equipment included the FU-G16ZY VHF set, the FU-G25A Erstling IFF transponder, and the FU-G125 Hermine blind landing navigation system. The Revi 12D gunsight, or Revi 16D on the A1 with Schwenkplatte mount, allowed accurate aiming for both guns and bombs. These features made the Do-335 highly versatile, but thorough testing was essential. The first flights revealed shortcomings: inadequate cooling for the rear engine, low elevator authority, and slight instability in level flight. However, its speed and handling exceeded expectations, and the ability to cruise on the rear engine alone, at up to 560 kilometers per hour, confirmed the tandem layout's advantages. Flight trials at Rechlin were conducted by 3 pilots: Hans Dieterle, Ivan Kvensler, and Werner Altrauge. On its 4th flight, the Do-335 reached 600 kilometers per hour at sea level, an impressive result. Pilots praised its easy handling even on one engine, though they noted the slight sinusoidal oscillation caused by unbalanced engine torque, which made accurate gunnery difficult. Additionally, spontaneous gear retraction issues delayed testing. Despite these flaws, the aircraft earned high praise, and in November 1943, Field Marshal Erhard Milch attempted to convince Adolf Hitler to support the program, highlighting the Do-335's ability to carry up to 1,000 kilograms of bombs, twice that of the Me-262. The design also offered passive protection. The rear engine acted as armor against attacks from behind, reducing the need for additional plating. The ability to cruise economically on one engine saved fuel. Yet the risk of damage to the rear propeller during takeoff or landing remained a serious concern, as did the danger during ejection. The propeller and tail separation system often failed, reducing the reliability of pilot escape. Even so, the Do-335 V1 demonstrated that the tandem layout could be viable for a high-speed combat aircraft, provided its technical challenges could be solved. The successful first flight of the Do-335 V1 in October 1943 marked the beginning of a difficult journey toward making the Dornier Do-335 Pfeil a combat-ready aircraft. While it showed impressive performance, its tandem engine layout created technical issues that became clear during trials. The most serious problem was the inefficient cooling of the rear DB603 engine. Located deep within the fuselage, it drew air through side-mounted intakes, but the flow was too weak, leading to overheating, especially at high altitudes. This reduced reliability and could cause engine failure during extended missions. Control authority was another concern. The absence of propeller wash over the tail surfaces meant that the elevator was less responsive, making precise handling difficult. At high speeds, the aircraft had a tendency for its nose to dip slightly, which added to pilot workload. Level flight stability also became an issue. Differences in torque between the forward and rear engines produced a gentle sinusoidal oscillation that impaired aiming accuracy. Test pilots, including Hans Dieterle, also reported the need to improve the hydraulic landing gear system, as the main gear occasionally retracted on its own, creating a risk during takeoff or landing. The pneumatic ejection system, though innovative, posed its own dangers. The jettison mechanisms for the rear propeller and cruciform tail were not always reliable, risking trapping the pilot during an emergency. Fixing these issues required time, something in critically short supply during wartime. The Do-335 also faced serious competition within Germany. The Luftwaffe was heavily backing the Messerschmitt Me-262 jet fighter, considered a priority project. Willy Messerschmitt used his influence within the Reich Air Ministry to argue that jet propulsion represented the future and that resources should be concentrated on the Me-262. His case was reinforced by the Me-262's top speed, up to 870 kilometers per hour, exceeding that of the Do-335. He also pointed out the production difficulties of the Tandem design, which required unusual components such as a long drive shaft and cruciform tail. In the resource-scarce environment of late-war Germany, this made mass production more complicated. However, the Do-335 had powerful supporters. Field Marshal Erhard Milch, responsible for aircraft production, saw the Pfeil as a promising multi-role platform. He believed it could serve effectively as an interceptor, bomber, and reconnaissance aircraft. Milch also stressed that a piston-engined aircraft was easier to integrate into the Luftwaffe's existing infrastructure than the Me-262, which required special fuel and new maintenance facilities. In December 1943, Milch secured a contract for 12 Do-335 prototypes, with a plan for 35 production aircraft to follow in 1945. Though modest for such an ambitious project, it gave Dornier a chance to prove the design's worth. Dornier's engineers experimented with redesigned air intakes to improve rear engine cooling, modified the elevator with balance tabs to enhance control response, and added dampers to the drive shaft to reduce oscillation, which partly solved the sinusoidal flight path issue. The Do-335 V2 and V3 prototypes were fitted with updated hydraulic landing gear systems that eliminated spontaneous retraction. But time was working against Dornier. By 1944, Germany faced mounting difficulties. Allied bombing raids crippled factories, and shortages of aluminium and steel slowed production. Competition with the Me-262 intensified when Adolf Hitler personally endorsed the jet fighter. In May 1944, he ordered its production accelerated, seeing it as a fast bomber for striking Allied forces. This decision diverted resources away from the Do-335, relegating the project to secondary status. Milch continued to argue that the Do-335 could be more effective as a versatile fighter, pointing out that it used standard aviation fuel and could carry up to 1,000 kilograms of bombs, twice the load of the Me-262. But these arguments were not enough to alter the Reich Air Ministry's priorities, and the Do-335 remained essentially an experimental program. Despite limited funding, testing continued. In January 1944, the Do-335 V3 was sent to the Rechlin Test Center for further evaluation. Pilots noted that it easily outpaced the Focke-Wulf FW-190 and Messerschmitt Bf-109, and that its high-altitude maneuverability was comparable to that of single-engine fighters. Cooling and control issues still required further modification, delaying readiness for mass production. During this period, Dornier also worked on the Do-335B night fighter variant, equipped with Fuji 220 Liechtenstein radar and a second cockpit for an operator, but the design never progressed beyond the drawing board due to resource shortages. Internal competition for resources and influence within the Reich Air Ministry slowed progress. Messerschmitt relied on political leverage to promote the Me-262, while Dornier counted on Milch's support and the technical merits of his aircraft. By mid-1944, it was clear the Do-335 would not enter mass production before the war's end. The limited order for 12 prototypes and 35 production aircraft was a step forward, but far from enough to realize the Pfeil's full potential. Germany's worsening military position, combined with shortages of materials and manpower, ensured that the aircraft's operational debut would come too late. By 1944, the Dornier Do-335 Pfeil was on the brink of combat service. But time and circumstances were against it. Following initial prototype trials, the aircraft was prepared for operational evaluation. In May 1944, the Do-335 V3 was delivered to the reconnaissance unit at Rechlin to assess its capabilities under combat-like conditions. This unit specialized in testing new aircraft, and the Pfeil was expected to prove itself both as a reconnaissance platform and as a fighter. A dedicated test detachment, Erprobungskommando 335, was formed at Mengen to trial the aircraft in the role of an interceptor against Allied bombers and reconnaissance aircraft. In August 1944, the unit received its first 3 aircraft. The Do-335 V5, V6, and V7, all armed with a 30mm Mk103 cannon and 2 20mm MG 151-20 cannon. During its time with Erprobungskommando 335, the Do-335 flew a small number of operational sorties. Its speed was remarkable, allowing pilots to evade even some of the fastest Allied fighters, such as the British Hawker Tempest and the American P-51 Mustang. In one encounter, a Do-335 successfully shook off a pursuing Tempest thanks to its top speed of 773 km per hour and its strong rate of climb. Actual combat use, however, was extremely limited, just a handful of interceptions and reconnaissance missions. The aircraft never became a frontline presence due to technical difficulties, organizational hurdles, and the rapid advance of Allied forces. One of the most serious concerns remained the pneumatic ejection system. Intended to provide safe bailout, it was prone to malfunction. Jettisoning the rear propeller and cruciform tail depended on a precise sequence of actions, and any delay or failure could be fatal. In practice, pilots avoided using the ejection seat, regarding it as unreliable. In one Rechlin trial, a hydraulic fault triggered the system unintentionally, forcing an emergency landing. The landing gear also caused trouble. The nose strut occasionally failed under the stresses of operating from rough airfields, sometimes damaging the fuselage or rear propeller. These weaknesses called for further development, but wartime resource shortages made such refinements difficult. Production itself was hampered by constant setbacks. By the end of 1944, Dornier's Friedrichshafen and Mansell plants had completed only 14 prototypes and 10 pre-series A0 aircraft. The plan for 1945 called for 35 production A1s, but shortages of materials and relentless Allied bombing meant the assembly lines ran erratically. By April 1945, only 61 aircraft had been built, many unfinished or retained for testing. The Do-335 V10 was tested as a night fighter with few G2-20 radar, but the variant never entered production due to a lack of components. Allied air raids on Dornier factories and suppliers, such as Daimler-Benz, further disrupted deliveries of DB603 engines and spare parts. Combat sorties were mostly limited to reconnaissance and occasional interception attempts. In December 1944, one Erprobungskommando 335 aircraft carried out a reconnaissance mission over Allied-held territory, returning safely thanks to its high speed and the ability to cruise on its rear engine alone. But no large-scale operations followed. The Luftwaffe's defensive strategy increasingly relied on the FW-190 and Me-262, both of which were simpler to build and more readily available. The Do-335, despite its advantages, was complex to manufacture. Its long drive shaft, cruciform tail, and non-standard undercarriage demanded high precision and specialist materials, which were in short supply. Pilot training posed another obstacle. The Do-335 required unique handling skills due to its unconventional layout. Pilots accustomed to single engine types like the BF-109 or FW-190 struggled with managing 2 engines, especially under asymmetric thrust. Shutting down the rear engine altered the center of gravity, affecting stability. Training new pilots for the Pfeil took time Germany no longer had. By 1944, the Luftwaffe was losing experienced airmen faster than it could replace them. As a result, most Do-335 sorties were flown by seasoned test pilots such as Werner Altrauge and Ivan Kvensler, who could cope with its peculiarities. By spring 1945, it was clear that the Do-335 would not have the chance to make a meaningful impact on the war. Allied forces were closing in, and Germany's aviation industry was on the brink of collapse. In April 1945, another bombing raid on the Friedrichshafen plant halted production entirely. Some completed Do-335s were flown to Bavarian airfields, but most never saw combat. When the war in Europe ended in May 1945, the Do-335 remained overshadowed by more famous aircraft such as the Me-262 and Fw-190. Only a handful of Airprobung's Kommando 335 aircraft had ever flown operationally, and their contribution was minimal, limited not by the design's promise, but by the realities of a war already lost. The end of the Second World War in May 1945 marked the conclusion of the Dornier Do-335 Pfeil's wartime story, but not the end of its history. After the fall of Germany, the Allies captured a number of completed and partially finished Do-335s at airfields and factories. The unusual design drew immediate attention, and the United States, the United Kingdom, and France began detailed evaluations to assess the Tandem layout's potential. Captured aircraft, including Do-335A0 and A1 models, were divided among the Allied nations for testing. These trials highlighted the Pfeil's strengths, but also underlined its limitations in the dawning era of jet aviation. In May 1945, France received 2 Do-335A0 aircraft, which were delivered to the National Flight Test Center. French engineers and pilots conducted a series of evaluation flights, studying the aircraft's speed, maneuverability, and reliability. The Pfeil confirmed its high performance, reaching up to 765 kilometers per hour at 4,000 meters, and showed potential as both a reconnaissance and interception platform. However, French crews encountered the same issues as the Germans: overheating of the rear DB603 engine due to inadequate cooling, and the questionable reliability of the pneumatic ejection system. In 1946, one aircraft crashed after a rear engine failure during a test flight. The pilot ejected successfully, but the propeller jettison system worked only partially, underscoring the hazards of emergency escape. The second aircraft remained in use until 1947, when it was retired due to wear and a shortage of spare parts. The United States captured several Do-335s, including prototypes and pre-production machines, which were shipped to Freeman Field, Indiana. American engineers focused on studying the Tandem layout and its aerodynamic advantages. During testing in 1945 and 1946, a Do-335A0 demonstrated exceptional speed and the ability to maintain stable flight on one engine, which improved fuel efficiency on long missions. American pilots praised its ease of handling at high speeds, but criticized the elevator's low effectiveness and the maintenance complexity of the long drive shaft. One airframe was sent to the National Advisory Committee for Aeronautics, NACA, at Langley, for comparative trials with the P-51 Mustang and P-47 Thunderbolt. The conclusion was clear: the Pfeil was faster than single-engine fighters, but inferior in maneuverability and production simplicity. The United Kingdom received a Do-335A12, the two-seat trainer variant with an instructor's cockpit. Tests were carried out at Farnborough in 1945 by the Royal Aircraft Establishment, RAE. British evaluations acknowledged its ability to carry 500 kilograms of bombs and its speed, but also identified weaknesses in the hydraulic landing gear system, which often failed under heavy loads. The RAE report suggested that the Do-335 could have been an effective interceptor or reconnaissance aircraft, but its complexity and reliance on specialized materials made it impractical for mass production. After testing, the aircraft was transferred to a museum, though it survived only in poor condition. One of the most valuable surviving examples was the Do-335A02, which reached the United States after the war. In 1974, Dornier repurchased the aircraft and brought it back to Germany for restoration. The work was carried out at the Oberpfaffenhofen plant, using original blueprints and surviving components to return the airframe to near original condition. In 1986, the fully restored Do-335A02 was transferred to the Deutsches Museum in Munich, where it remains the only complete surviving example. Equipped with DB603A1 engines, a 30mm Mk103 cannon, and two 20mm MG 151-20 cannon, it stands as a tangible example of the Pfeil's unique engineering. Allied testing showed that the Do-335 had real potential, but its moment had passed. The arrival of jets such as the British Gloucester Meteor and the American P-80 Shooting Star rendered piston engine fighters obsolete. The tandem layout, though capable of producing high speeds with low drag, was too complex for large-scale manufacture and maintenance. French engineers considered adapting aspects of the Pfeil for their own projects, but ultimately shifted focus to jet propulsion. The Americans and British reached similar conclusions. The tandem arrangement might serve for experimental designs, but was unsuitable for frontline production in the new aviation era. Even so, the Do-335 left a mark on post-war experimentation. Its design influenced projects such as the American McDonnell XP-67 Moonbat, which adopted a similar unconventional layout but never advanced beyond the prototype stage. In France, Dornier's ideas echoed in high-speed prototype work, including the Arsenal VG-90, though these too remained experimental. In post-war Germany, Dornier returned to civil aviation, but the lessons learned from the Do-335 helped the company maintain its reputation for innovation. The preserved Do-335 A02 has become a symbol of engineering ambition, a machine ahead of its time, yet overtaken by the rapid rise of jet technology. Nearly 8 decades after its creation, the Pfeil remains a reminder of a brief chapter in aviation history, when engineers searched for unconventional ways to push piston-powered flight to its limits. Although the Dornier Do-335 Pfeil never reached mass production, it retained a place in aviation history, its unique tandem layout and innovative solutions inspiring a number of post-war design studies. By 1944 and 1945, as the war was drawing to a close, Dornier explored several derivative concepts based on the Pfeil, aiming to adapt its core design to meet emerging operational needs. These projects never advanced beyond the drawing board, but they illustrated how the Pfeil's ideas might have evolved under different historical circumstances. The Do-435 was envisioned as an improved version of the base model. It retained the tandem configuration but substituted more powerful DB603E1 engines, aiming for a top speed of 800 km per hour. Planned upgrades included an extra 30mm Mk103 cannon in the wings and increased bomb capacity to 1,000 kilograms via ETC-504 external pylons. The design also featured an improved rear engine cooling system with larger intakes and a redesigned radiator. Work ceased at the design stage when Germany capitulated in May 1945. Specifications had been approved by the Reich Air Ministry, but Dornier's plants soon came under Allied control. Even more ambitious was the Do-535, which combined the tandem arrangement with a jet engine. The forward DB603A1 piston engine was retained, but the rear unit was replaced with a Heinkel-Herth Schiess-011 turbojet, producing up to 1,300 kilograms of thrust. The combination was projected to boost top speed to 850 kilometers per hour and improve high-altitude performance. The Do-535 was conceived as a radar-equipped interceptor for night operations using the Fuji-240 Berlin set. Integrating a turbojet into a fuselage designed for a piston engine proved complex, and in 1945 the project was transferred to Heinkel, only to be canceled due to resource shortages and shifting priorities. An intriguing offshoot came from Junkers in the form of the Ju-635, inspired by the Do-335's concept. This design proposed a twin-boom arrangement with 2 fuselages, each housing a tandem DB603 installation connected by a central wing. The Ju-635 was intended to carry up to 2,000 kilograms of bombs and reach speeds of 780 kilometers per hour, serving as a heavy fighter or bomber. Armament plans included 4 20mm MG 151-20 cannon and 2 30mm Mk 108 cannon for bomber interception. The aircraft's structural complexity and the acute material shortages of 1945 doomed the project. Work halted at the mock-up stage and the drawings were lost after the war. All of these proposals reflected the post-war aviation shift toward high-speed, multi-role aircraft capable of competing with jets. But the advent of operational turbojets such as the Jumo Harjoe-4 and the Rolls-Royce Derwent fundamentally altered design priorities. The tandem layout, the Do-335's defining strength, lost relevance due to its production and maintenance complexity when compared with jet aircraft. The American P-80 Shooting Star could reach 960 kilometers per hour without the complications of a long driveshaft or cruciform tail, while Britain's Gloucester Meteor set the standard for post-war fighters with its simplicity and reliability. Still, the Pfeil's ideas did influence the thinking of other designers. The tandem concept inspired experiments in the United States, most notably McDonnell's XP-67 Moonbat, which adopted a similarly unconventional approach in a twin-boom configuration. In France, elements of the Do-335's layout could be seen in the Arsenal VG-90 prototype, which combined a pusher propeller with a jet engine. These two remained experimental. Jet propulsion had already proven its superiority in speed, agility, and production efficiency. In the Soviet Union, tandem schemes were studied for heavy fighter designs, but the conventional layout of aircraft like the MiG-15 ultimately prevailed. The Do-335's significance lay in its technical capabilities and in showing how creative engineering could produce unconventional solutions under crisis conditions. Claudius Dornier built an aircraft that combined the speed of a single-engine fighter with the versatility of a twin-engine bomber. Its ability to cruise on one engine, carry a meaningful bomb load, and shield the pilot from the rear with an engine block was unique for its time. War and resource shortages prevented that potential from being realized. In the post-war years, Dornier turned its attention to civil aviation, producing designs such as the Do-27 and Do-28, yet the experience of developing the Pfeil remained a formative achievement for the company. The Do-335 became a symbol of wartime innovation, proof that even in the most challenging circumstances, engineers could create technically advanced machines ahead of their time. The preserved Do-335A02 at the Deutsches Museum in Munich stands as a reminder of this brief but remarkable episode in aviation history, when bold engineering contended with the limits of time and resources. The Dornier Do-335 Pfeil remains one of the most distinctive yet underappreciated aircraft of the Second World War, an example of how bold engineering could produce unconventional solutions under the intense pressures of wartime. Its unique tandem arrangement with one tractor and one pusher engine allowed it to reach 773 kilometers per hour, making it one of the fastest piston-powered aircraft of its era. The ability to carry up to 1,000 kilograms of bombs, operate as an interceptor, reconnaissance platform, or bomber, and cruise economically on a single engine demonstrated the versatility the Luftwaffe so badly needed in 1943-45. Limited resources, unresolved technical problems, and the rapid emergence of jet fighters prevented the Pfeil from realizing its full potential. The Do-335's design was a leap forward. Its pneumatic ejection seat, cruciform tail, tricycle landing gear, and armored cockpit were ahead of their time, but these innovations added complexity to production and maintenance. Only 61 aircraft were built before the war ended, most never seeing combat. Chronic rear-engine cooling issues, the unreliable escape system, and competition from the Me-262, which received top priority from the Reich Air Ministry, kept the Do-335 from influencing the course of the air war. Even so, its engineering significance is beyond dispute. The Pfeil proved what German industry could achieve under crisis conditions. In 1944, with Germany suffering shortages of materials, manpower, and time, Claudius Dornier created an aircraft that combined the speed of a single-engine fighter with the versatility of a twin-engine bomber. His ideas, such as using the rear engine to shield the pilot from attacks and keeping the wings free of engine nacelles to reduce drag, were innovative. After the war, as jet aircraft eclipsed piston types, the Do-335 remained a case study in overcoming technical barriers with unique solutions. The symbolic closing chapter of the Pfeil story is the preservation of the sole surviving Do-335A02 at the Deutsches Museum in Munich. Restored between 1974 and 1986, this aircraft, armed with a 30mm Mk103 cannon, two 20mm MG151-20 cannon, and powered by DB603A1 engines, serves as a living reminder of an ambitious project that left its mark on aviation thinking. Allied testing in the United States, United Kingdom, and France confirmed the Pfeil's promise, but its fate was sealed by the shift to jet propulsion. Tandem engine concepts resurfaced in designs such as the American XP-67 and the French VG-90, but none reached mass production. the Do-335 stands as proof that innovation can emerge even in the chaos of war. In 1943, as Germany's fortunes declined, Dornier produced an aircraft that might have met those challenges. Given more resources and time, its history speaks of technical achievement and the determination to find new paths when old ones had lost their edge. For those fascinated by Second World War aviation, the Dornier Do-335 Pfeil illustrates how creativity can thrive under the harshest conditions. It tells the story of potential left unfulfilled. Would it have changed the course of the war if it had entered mass production earlier? Was its design a triumph, or was the tandem configuration destined to remain a technological curiosity? Share your thoughts in the comments, pass this story along to fellow enthusiasts, and subscribe to the channel for more accounts from aviation history. Next time, we'll explore another unusual aircraft of the Second World War that deserves a closer look. Thank you for watching, and see you in the next video.